Hi, this is Shannon Seaver. Today we're looking at 3-7 arguments in Euler diagrams. Our agenda today is to use Euler diagrams to determine the validity of arguments. So first of all, who is Euler? And he is a genius Swiss mathematician who published an average of 800 pages of new mathematics a year, which is an amazing feat. He's a super genius. So I just wanted to point out, though, it's not pronounced Euler, like Ferris Bueller. It's pronounced Euler. Okay, so whenever I say Euler diagram, you can kind of picture E-U-L-E-R, okay? So what is an Euler diagram? It is used for arguments that have quantified statements. And remember, quantified statements are those statements that have all, some, or none, or no. So it doesn't work for regular types of statements, but it will work for quantified. So here's some examples, and they look a lot like Venn diagrams. So this first one, all A are B. You notice that A is inside the diagram of B. And by the way, I think that you need to write these 4 examples down just to make sure that you have an idea of what they are. The second one is A and B. Notice that they're not touching, they're not crossing, one's not inside the other. So this one is no A are B. And the next one we have some A are B. And notice that they're intersecting and there's a dot in the middle of it. So that means there's at least one in there. And the last one, some A are not B. So this time we're talking about something that's inside the A part, but not in the B, yet the two are intersecting. So they are very much like Venn diagrams, and it just really helps to use these to determine if something's valid or not. And I'm going to show you how to do that in a minute. So how do we use an Euler diagram? First of all, you have to make an Euler diagram for the first premise. So you should have 2 circles involved in that very first premise. Number 2, you're going to make an Euler diagram for the second premise, and you're going to put it somewhere, either inside the first premise, or on the side, or outside of it, depending on what it's saying to you. And right now that may not make sense to you, but it will in a minute when I show you. The third part, the argument is valid if and only if every possible diagram illustrates the conclusion of the argument. If there's even one possible diagram that contradicts the conclusion, this indicates that the conclusion is not true in every case, so the argument is invalid. So let's put these rules into action. Let's look at this example. We're going to use an Euler diagram to determine whether the following argument is valid or invalid. All people who arrive late cannot perform. All people who cannot perform are ineligible for scholarships. Therefore, all people who arrive late are ineligible for scholarships. So the first thing we need to do is to make an Euler diagram for the first premise. All people who arrive late cannot perform. It should look like this. Notice that the circle with the people that arrive late is located inside the circle of those that cannot perform. Now I need to make an Euler diagram for the second premise. All people who cannot perform are ineligible for scholarships. Where would we put that circle? So if you notice, this is the outcome of that. All people that cannot perform is located inside the circle of ineligible for scholarship. So therefore, all people who arrive late are ineligible for scholarships. Notice that the arrive late is indeed inside the ineligible for scholarships for this case. So this is a valid Euler diagram that shows that the argument is indeed valid. It works for every case. Now let's look at another example. All U.S. voters must register. All people who register must be U.S. citizens. Therefore, all U.S. voters are U.S. citizens. So our first part is to write the Euler diagram for the first premise. U.S. voters are inside the register. So the next part is to talk about people that register must be U.S. citizens. So this is a similar one to the last one that we were looking at, because notice that the register is inside the circle of U.S. citizens. So for this one, indeed, U.S. voters, which happen to be inside the register, is also inside the U.S. citizens. So this is a valid argument as well. Now, let's look at something that might be a little different. All poets appreciate language. So the first thing we're going to do is put poets inside of appreciate language. The second part says all writers appreciate language. So one of the things you need to know is that means it could be inside here. It doesn't say anything to do with poets. So we could have writers here. We could have writers here and intersecting with poets. We could also have writers on the outside of poets. We could have writers on the inside of poets. But notice that we have 4 different possibilities on this one. This one's a lot more loose. And the fact that we have so many different possibilities means that this is an invalid statement, because all poets are writers. Well, this one case right here where the writers are outside and where some of them are on the outside means that not all poets are writers. So in the Euler diagrams, what you need to find, anytime you have something on the outside that doesn't work on these Euler diagrams, then it's not valid. Okay, so now it's your turn. Try this particular one and then turn back on the video to see the answer. So on this particular Euler diagram, notice that Aristotle is inside of men there, inside of mortal. So this is a valid argument. Now try this one. Notice that on this one, Jeff could have been inside the swim in 2 different places. He could have been inside the circle one, or he could have been inside, just outside the circle, inside the swim circle. So this is not a valid argument because it doesn't prove that Jeff is indeed a child. It could have been in either case. So that is the end of my video for today.